Hello, welcome to lesson 8. In this lesson, we are going to look at the examples on the use of the mirror formula, the relationship connecting M, V, and F, that is the magnification, the image distance, and the focal length, and also the relationship connecting M, U, and F, which is the magnification, the object distance, and the focal length. And then lastly, we shall also look at the examples on the relationship connecting M, V, and F, and also M, U, and F. Let us begin by looking at the examples on the use of the mirror formula. This is our first question. An object 1 centimeter tall is placed 30 centimeters in front of a concave mirror of focal length 20 centimeters. Find the position of the image, the size of the image formed, and then lastly the magnification of the image. Now here in this question they have given us the height of the object, and it is 1 centimeter, and then the object distance is 30 centimeters, and then it is a concave mirror, which means that the focal length is going to be negative of 20, and therefore we can get the V using that. Let's summarize that. And so here we can see that we are lacking V, we have U and F, so we can use the mirror formula, and we shall make V the subject. So we shall have 1 over V is equal to 1 over F minus 1 over U, which is 1 over 20 minus 1 over 30, which is 1 over 60. 1 over V is equal to 1 over 60. Cross multiply, we get V as 60 centimeters. It is positive, which implies that it is real. So the image is real. Next part. Size of the image formed. Remember, we want the size. We have already the size of the object. So we have H naught. We need HI, which is the height of that image. But we know V and we know U. So using the magnification formula, we have M is equal to HI over H naught, which is equal to V over U. And therefore, but we know that this one is 60 divided by 30, which is 2. And then this is HI divided by 1. So if you make HI the subject, we shall have HI as 2 centimeters. Let's also look at the magnification. You can just use either V over U or HI over H naught. V over U is equal to 60 divided by 30, which gives you 2, and it is without any unit. Then also we can use HI over H naught, which is 2 over 1, which still gives you 2 without units. Magnification has no unit. Next example. An object 10 centimeters tall, the height is 10, is placed 30 centimeters in front of the convex mirror. U is 30. It is a convex mirror, means that the focal length is going to be negative of 20. Find the position and then the size of the image formed. So for the position, that is V, we need to use the mirror formula. And if you use the mirror formula, we shall make U the subject. So the V the subject, because it is the position of the image. So it will have 1 over V is equal to 1 over F minus 1 over U, which is going to be equal to 1 over negative 20 minus 1 over 30, which is the U. It is negative, F is negative because it is convex. And therefore we shall have 1 over V is equal to negative 5 over 60, which gives us V as 60 divided by negative 5. And that will give us negative 12 centimeters. It is negative, which implies that the image is going to be virtual. The image is going to be virtual, or it is going to be behind the mirror. 12 centimeters behind the mirror. The magnification, same formula. That's what we want. And remember we have our H naught, which is 10. HI we don't know. V is 12. And then U is 30. We shall not consider the negative here because we just want the magnitude of the height. So the negative is not important. So we shall have that as 12 divided by 30. HI divided by 10. HI the subject, make HI the subject, and we shall have 4 centimeters. The third example here. A concave mirror with a radius of curvature 40 centimeters forms an image of real object which is placed 25 centimeters from the mirror. So the concave mirror means it is positive still. The radius of curvature is positive, and therefore the focal length is also going to be positive. So we shall discuss this very well. What's the question here? What is the focal length of the mirror? And then also they want us to get the distance of the image from the mirror and also talk about its nature. Now let's begin by getting the focal length. Focal length, we have the radius of curvature. Remember, r is equal to 2f. So f is going to be r divided by 2, which is going to give us 40 divided by 2, which gives us 20 centimeters. So the focal length is 20 centimeters and it is positive. Now we also need to get the distance of the image. Remember, we have the u. U is 25, so we shall use the mirror formula in that case. And then make v the subject, which is going to be 1 over f minus 1 over u, which is 1 over 20 minus 1 over u, which is 25. And therefore we shall have 1 over v is going to be 1 over 100, which makes v equal to 100 if we cross multiply 100 centimeters, and it's going to be positive. Positive, which means that the image is going to be real. And also if we divide 100 by the 25, we get 4, which is magnified, because as long as the magnification is greater than 1, then it means that the image is magnified. The image of an object in a convex mirror is 6 centimeters. Convex, if the image in a convex mirror is a convex mirror, that means that it is going to be negative. The sign convention is going to be negative because it is convex. And then they are saying that if the radius of curvature of the mirror is 20 centimeters, find the object position and the magnification. Okay, that's very okay. They want us to get the u and the m. Now, we already know that our radius of curvature can be got using, our focal length can be got using the radius of curvature. So f is going to be negative 20 divided by 2, which will give us negative 10, because it is a convex mirror. Then also, we know that it is negative because this is a convex mirror, so the v is negative, because it is always virtual. Now let's use the mirror formula and make u the subject. If I make u the subject, I will get, okay, first of all, I shall get 1 over u is equal to 1 over f minus 1 over v, which is going to be 1 over u is going to be 1 over negative 10 for the f, minus, because we shall take this on the other side, and then we shall get minus 1 over negative 6, because the v is negative, it being virtual. And therefore u is going to be 15 centimeters. The magnification is going to be v over u, which is going to be negative 6 over 15, or you can just say 6 over 15, since we want just the magnitude. 6 over 15, which gives us 0.4. So the magnification is going to be 0.4. Let's look at the relationship connecting m, v, and f. Here we shall just use the mirror formula. Get the mirror formula. If you want connecting v, we shall multiply by v. Multiply through by v. And if you multiply through by v, we shall have v over f is equal to v over u, which is actually m, plus v over v, which is 1. So we shall have this. And therefore we shall have our m as v over f minus 1. That relationship is very, very important for us. Then also, if you want the one connecting m, u, and f, we shall multiply this time around by u. We shall multiply the mirror formula throughout by u. So if you multiply throughout by u, we shall have u over f is equal to u over u, which is 1, plus u over v, which is the reciprocal of the magnification. Yeah, so we shall have u over f is equal to 1, because it is u over u, plus 1 over m. And therefore 1 over m is going to be u over f minus 1. That equation, or that relationship, is also very important. Let's look at the examples on that. Our first example, a small object, this is object, placed in front of a spherical mirror gives a real image and 4 times the size of the object is real. That means that that's first case, the 4 is going to be positive. When the object is moved 10 centimeters towards the mirror, so the object was shifted from a certain position towards the mirror by 10 centimeters. But this time round, it forms a similar magnified virtual image. Similarly magnified virtual image. That means that still the magnification is going to be 4, but it's going to be virtual. That means that it's going to be negative 4. Find the focal length of the mirror. You want us to get the focal length of the mirror. So in this time round, we shall use m is equal to v over f minus 1. The first relationship, m is equal to v minus 1. And then shall make v the subject, since we are dealing with the relationship here they have given us when the object is moved that. So we are dealing with actually here we are dealing with the object distance. So we shall use the relationship which has u. So we shall use this other relationship which has u. So we shall use 1 over m. 1 over m is equal to 1 over m is equal to u over f minus 1. And therefore shall make u the subject and shall have u is equal to 1 over m plus 1 over m plus 1 times f. So shall give this a subscript 1 1. So we have u1 and then m1 because we have two m1 and m2. And then shall also have u2 is equal to 1 over m2 plus 1 times f. So we shall have these two equations. Now since they have said that it was moved towards, it means that u2 is smaller than u1. u1 is greater than u2. And so we shall subtract u2 from u1, which will give us 10. And that is going to be 10. So let us subtract equation 1 minus equation 2 and make u1 and u2 and make f the subject. Since we want the focal length, make f the subject. If you make f the subject, shall have u1 minus u2 divided by 1 over m1 minus 1 over m2. But we know that u1 minus u2 is equal to 10, so we shall replace 10 there, and then also replace for m1 and m2 with the 4 and negative 4. And when we divide that, we shall get f as 20 centimeters if you work out this. Next example, a concave mirror forms a real image which is 3 times the linear size of a real object. When the object is displaced a distance d, the real image formed is 4 times its linear size of the object. If the distance between the image's position is 20 centimeters, find the focal length of the mirror, and then they also want us to find the distance d. So here we have the magnification. The first magnification m1 is 3, and then when the object is displaced, the second magnification is going to be 4 times. What does that mean? It means that now here they've said it is real, which means that m is positive, and even here is real, so m2 is also positive. But now they've given us the focal length. So it means the focal length, and then they want us to get the focal length, and then we have the m1 and m2. So here we are going to use the first relationship, which is m is equal to v over f minus 1. That's what you're going to use because we have the v. So here we shall make v the subject. First of all, we shall make v the subject since we have the difference between v1 and v2 as 20. Make v the subject and have v1 is equal to m plus 1 times f. So it is m1 plus 1 times f, and then also v2 is going to be m2 plus 1 times f. So those are the two equations we shall come up with. And then after getting those two equations, remember they've told us that the difference is 20. Now, since the magnification is increasing, it means that v2 is going to be greater. Since m2 is greater than m1, also v2 is going to be greater than v1, since we know that m is proportional to v, since we know m is equal to v over u. So it implies that we shall have our v2 minus v1 as 10. The difference is going to be 10. And then we shall make f the subject. If we want to make f the subject, let us subtract equation 2 minus equation 1 and make f the subject. And then we shall have that as v2 minus v1 divided by m2 minus m1. And then we shall have 20 divided by 4 minus 3, which gives us 20 divided by 1, which is equal to 20. Then the next question, the distance. This time round we can use the second equation, the second relationship, where we have u, because here we have the distance d, and the distance d is actually the displacement of the object. So we want to get the difference between u1 and u2, so we shall use the second one. But we know that u is inversely proportional to m, so since m2 is greater than m1, so u1 is going to be greater than u2. So this time round we shall note that u1 is greater than u2, so we shall be getting u1 minus u2 to give us the d. Now let's use this second one. Since we are talking about u, we shall use the second one, which has u. Then we shall have 1 over m is equal to 1 over u, so the u over f minus 1, and then make u the subject. We shall get u1 is equal to f over m1 plus 1, and then also u2 is going to be f over f over m2 plus 1. Now we have the two, u1 and u2. We shall subtract 1 minus 2 and make f the subject. Since we want d, we shall get u1 minus u2, the difference, the displacement d. And then we shall get u1 minus u2, which will give us this. And when we get that, we shall replace f with 20, and then m1 with 3, and then m2 with 4. And that will give us 1.67 centimeters. We can also get this d, the shift in the object position. We can also get it using the mirror formula. Since we have the v1 and v2, we can get v1 and v2 since we have this f. And then after getting v1 and v2, we shall use we can use the mirror formula. We can use the mirror formula to get u1 and u2, or we can even use the magnification to get the u1 and u2, and then get the difference between u1 and u2, and still to give us 1.67 centimeters. Let us also look at this. A concave mirror forms on a screen a real image of 3 times the size of the object. The object and the screen are moved until the image is 5 times the size of the object. If the shift of the screen is 30 centimeters, that is the change in the image position, determine the focal length of the mirror and then the shift in the object. Now the magnification m1 is 3 and then m2 is 5. They are all positive because they are real. So we shall do the same thing using m is equal to v over f minus 1. Shall make v the subject. So we shall have v1 is equal to m1 plus 1 times f, and then v2 is equal to m2 plus 1 times f. This time round, we also know that m2 is greater than m1, and so v2 is greater than v1, and therefore we shall subtract v2 minus v1, which is going to be equal to 30. And therefore we shall subtract equation 2 minus equation 1 and make f the subject, which will give us that, and that will give us 30 divided by 5 minus 3, which will give us 15 centimeters as the focal length. Shift in the object position, we shall use the same thing, same method like in the previous question, and then we shall have m2 greater than m1, implying that m1 is greater than, u1 is greater than u2 because m is inversely proportional to u. Make u the subject from that. Then you have u1 is equal to f divided by m1 plus 1, and then also u2 is f divided by m2 plus 1, and then we shall subtract the 2. We shall subtract the 2 and get that shift. So we subtract the 2 and get the shift. So when you subtract u1 and u2, we shall get a shift, and then we shall have f divided by m1 minus f divided by m2, which will give us 15 divided by 3 minus 15 divided by 5, and that will give us 2 centimeters. Yeah, thank you for your attention. See you in the next lesson.